This video is a continuation from the previous. Okay, so wind. Wind is something we have to consider. Air movements at a site should be studied during different parts of the day and during different seasons if possible. The good news is you don't necessarily have to do that. That data should be attainable. Once the wind patterns are known, the building should be oriented to take full advantage of the cooling effect of wind directions or oriented to avoid cold winter winds. And as most of you have heard of, the jet stream is the flow of air pattern across the world. And in North America, we have polar air that mostly goes through Canada. Every once in a while, that polar jet stream will dip all the way down to Mexico, the border with Mexico. And that's when, unfortunately, it can do some serious destruction to the crops. The strongest one that drives this mostly, though, is this mid-latitude jet stream. And then we have a subtropical. And when we get those heat waves, all these may shift up, and this subtropical could come through. And that's really sometimes we get those sweltering summer heat, because this brings with it the humidity. So knowing these things are important to understanding how to design the residence, how to orient the house on the site. And the jet streams, by the way, are controlled by the temperature of the winds. And you can find this through many different sites. There is a global wind atlas. There are also NOAA, National Oceanic Administration. Sorry, I don't know what the other A stands for. And there are all kinds of tools and things that the government puts out so that you can look this up. So you don't actually have to tell your client, well, we can start designing in a year because I'm going to go out there every day and check the wind. They'd be like, okay. No. And then your wind orientation will help you decide other things too, like what are you going to plant for sustainable design. Coniferous trees provide excellent windbreak because they are evergreen. They don't drop their leaves. Well, I don't want to say that. I've seen pine trees go brown and drop their leaves, but not all of them drop their needles. They will lose their leaves and grow new ones, of course, but not all at the same time. They don't go dormant. They're still awake in the winter, and they are called evergreen as a result. They're terrific windbreak. So if you have a heavy wind and the only thing you can do is plant trees. That is very sustainable. Natural ventilation during the summer will help to cool the house. So if you plant trees that provide shade so that the breeze that comes through is cool, that will help reduce your HVAC demand, and that is also sustainable. Now, deciduous trees provide that cooling shade during the summer. They drop their leaves. So a tree that is planted on the face that gets southern exposure, the face that points north, in the summer could block the sun if it's a big tree like the elm or the oak. And then when it drops its leaves in the winter, now it's no longer an impediment to the sun getting into the house and warming it up. So trees, very, very great way to not only make the site beautiful, but to provide sustainable effects. And then if we're building in the city, we have to be very careful about wind turbulence. Obviously, this is showing the plane being upset by that. But large buildings, if you have two large buildings, it creates a wind tunnel. And you don't want, if you're going to build in between two large buildings, you're going to have to consider the fact that there is going to be that wind effect that comes into play. Buildings near water have additional consideration, as the winds will act over bodies of water in ways that can provide both challenges and benefits. Designs can take advantage of that continuous breeze that is generated from waterfront properties. But they can also generate excessive winds, so there's that consideration too. And so you can do a wind analysis plan. And obviously, the main to consider are summer solstice and winter solstice, because those are your extremes. And so if you can design for those two extremes in mind, you'll meet the range that's in between. And here's an example. Site section through this building shows, okay, so here's my summer sun, and this is a deciduous tree planted near my house, so that it blocks, because it's going to have leaves, it's going to block. Also, I'm going to have these large overhangs. So I'm really going to prevent this sun from having much an effect, or reducing its effect on the heating, the thermal mass inside my home. And then in the winter, it's going to drop its leaves, and I'm now going to get more sun into my space. And then there are all kinds of things you can do with your floor materials so that they will collect and then radiate out the heat at night. There is a lower window that opens. This one's fixed, and this window opens out. So this lower summer breeze can come through and out. Any time you can ventilate your house through cross ventilation, you really lower your carbon footprint. The earth berm here is also helps with sustainable design. We'll look more about that in a couple of slides here. And then what it does is this allows the wind, the cold winter wind comes this way, travels up the berm and does not hit the house directly. It travels over the roof. And so this berm helps control the cold winter winds from penetrating the house. And, here's basically a site plan based on knowing the wind data, the prevailing wind coming in this way, and planting some trees here. The sun's coming in this way, so we want to put our solar collectors on that side of the house. And then large overhangs, which you can't see here, but we would see that on the plan. And more trees to help block that summer sun. Okay, so there's something called, earth-sheltered homes. And this is basically when you have buried most or all, almost all, not entirely, obviously you got to get in it, your building in the ground. And one of the reasons people do this is the ground stays an average temperature year-round. It's about annually stable around, it depends on the area, of course, but it's around 54 degrees underground. If you have a crawl space in a basement, if you go in there, it'll be cold year-round. Well, if you find 54 degrees cold, it'll be cold year-round. If you find it warm, it will be warm year-round. I don't know if you've ever done one of those tours, one of those caverns. It's at 50-something degree range year-round. And so by putting your house there, you have a more stable environment, and you have passive annual heat storage. And here is a cross-section of what one looks like. And of course, there's some exposure to sunlight because we need sunlight. Part of our health is dependent on our eyes being able to, and skin being able to absorb sunlight. We make vitamin D and become vitamin D deficient if we don't get enough. So, but also natural sunlight coming into the house rather than turning on the lights, more sustainable. I don't know, I'm having a problem saying that word. It's just a word I don't, sustainable. I don't think I'm out right. Okay, and so there's some different types. This one is like, as you can see, almost fully underground. You have to go underground to get in, and then there's just some access to light out through skylights. This one has, so this one's no exposed walls. It's just only open at the entry. This one has one exposed wall. This one has some exposed walls. And this one has walls that open to a central courtyard. And here is a prefabricated metal panel So the metal panels are already prefabricated and they brought them out. And then they've excavated, and then they're going to cover this back up. And I will tell you, the most prohibitive, two prohibitive things about this is it's very expensive to move dirt around. So you have to be really good at it. And you want to do as little cut and fill as possible, but you're going to have to be doing a lot of digging. And then of course the other is waterproofing. And those are the two big challenges in this. Vegetation aids greatly in heat, light, wind, humidity, and noise control. So how you do this is important. A lot of my friends who are building designers hire landscape architects, the people who know this very well. It could be something you pick up in addition. I would highly recommend taking courses to learn about this. It's not something you're just going to do a little bit of research on and get really good at fast. So it's definitely people do make entire livings just doing landscape design. I will say one exception, and you have to be careful if you're planting too close to a building on the northern exposure during the summer. It can actually trap heat. It's the one thing you want to be careful of. Most of the time, plant away, right? Plant as much as possible, much as you want. But it's one of the times, or planting something like a pine tree next to your house. You don't want to do that either. They tend to fall over by the roots sometimes. If they die and there's a strong wind, it'll knock them right over right on your house. Okay, we're going to stop here and continue in the next video.